Alright, 7.3, solving exponential equations. So this is nice, it's a little bit different than what we've been doing so far, so no more graphing for a little bit at least. Now we're going to go back to some previous knowledge, so rewrite each expression as a power with a base 2. So this is something you might have done possibly in grade 9, more likely. So base 2, right now the base is 4. Well, I know that 2 squared is equal to 4. I still have that 3 though on the outside of those brackets. Now we have an exponent law, so we go 2 times 3, and that gets us 2 to the power of 6. Now for b, it's a little bit trickier. We've got 1 over 8 as our base. So then that means I'm going to want to reciprocate that first. So it's going to become 8 to the power of negative 1. And then 2 to the power of 3 is 8, but I still have this negative 1 hanging out here on the outside. So 3 times negative 1 is negative 3. Finally, we have c. Now, we've got 2 different bases here, so I'll deal with the first one of 8. So we have 2 cubed is 8, and then that's still to the power of 2/3. And over here, something a little bit different. We've got a square root. So now, 2 to the power of 4 is 16, and we still have to keep that square root for now. And then we should simplify as much as we can. So 3 times 2 over 3, well, these are inverse operations, so we end up with 2 squared. Over here, we're going to use flower power. So our power is 4, and our root is 2. And that's still all to the power of 3. So now we have 2 squared. Now 4 divided by 2 is 2. 2 times 3 is 6. Now when we're multiplying, same base, we're going to add the exponents. So we get 2 to the power of 8. So sticking with some previous knowledge, I want to solve these next 4 questions. So we have x cubed equals to 8. Well, the opposite of cubing something is cube rooting it. So I'm going to cube root both sides. So that means x is equal to 2. Our next question, x to the power of 1/4 equals 2. Well, the opposite of 1/4 is going to be to the power of 4. And so what we do to one side, we need to do the other. So we get x equals 2 to the power of 4, which is 16. Now this one's a little bit trickier. We have to think that if we were doing a multiplication, so for instance, 3 to the power of over 5, and we wanted to turn this into 1, we'd actually go 5 over 3. So we'd multiply by the reciprocal. So basically, we're going to take both sides to the power of negative 5 over 3. So this side becomes 1 as the exponent, so we just have x left over. Here we're going to use flower power to solve this, so it's a cube root of 27 to the power of 5. Now I'm going to ignore the fact that it's negative for a second, so I'm going to keep that on to the power of negative 1. We can do the cube root first or the power first. I know that the cube root of 27 is 3, so to me that's a little bit easier. So 3 to the power of 5, all to the power of negative 1. And then we can go 3 to the power of 5, which is 243. Still all to the power of negative 1. And then we're going to reciprocate 243 to get rid of the negative exponent. So we have x equals 1 over 243. All right, our last one, we'll do something very similar. So I'm going to raise both sides to the power of 3 over 2. What I do to one side, I do to the other. So again, this is going to equal to 1. So I'm just left with 16x. And here we can use flower power again. So we've got a root of 2 and a power of 3. So we're going to simplify that first. I'll do the square root. Square root of 4 is 2. It's a little bit easier. And then 2 cubed is 8. And then I'll divide both sides by 16. And I end up with 1/2. Now let's actually look at some grade 12 questions then. So again, we have solve. But now we have the variable is actually in the exponent, which causes a bit of an issue. So what our strategy is going to be is to make the base the same. So here we've got a base of 2, here we got a base of 8. Well, I can do a change of base to this 8 to make it a base of 2. So that's what I'll do. So the left side stays as the same. And 2 cubed is the same as 8. Now I'm going to put this x minus 1 in brackets because we are going to have to distribute that 3 to both of these. I could have put the 2 cubed in brackets and then this x minus 1 all on the outside. It would have meant the same thing. Now that we have the left side and the right side base the same, I actually can just make the exponents equal to each other then. So 2x plus 1 equals, I'll do the distribution right now, so 3x minus 3. And now I'm just simplifying. So I'm going to subtract 2x off both sides, so I'm left with x, and then I'll add 3 to both sides, so I get 4. So therefore x is equal to 4. So it's actually not too bad. It looks a lot worse than it really is. All right, our next one. So again, I have a base of 2 and a base of 32. Well, I can make 32 become a base of 2. So the left side is going to stay the same. And 2 to the power of 5 is 32. And again, now that we have the same base, we can make the exponents equal to each other. And again, I'll do the distribution. So 5 times x is 5x, and 5 times negative 2 is negative 10. I will subtract 3x off of both sides and add 10. So I'm left with 2x equals 10. Divide both sides by 2, and so I get x equals 5. All right, our third question. It looks a little trickier because it's maybe not as obvious that these have the same base. Like there's no way I can go from 16 to 8. However, these are both powers of 2. Like this can become 2 to the power of 3 and 2 to the power of 4. And so again, we'll do a change of base. So we get x minus 1 equals 2 to the power of 4, x minus 2. Now we can write these exponents that they're equal to each other. Again, I'll do that distributive property right now. So 3x minus 3 equals 4x minus 8. And I will add 3x, I'll subtract 3x from both sides and add 8 to both sides. So then I end up with 5 equals x. All right, one last question like this. It looks a little tougher because we have this fractional exponent now, but don't worry, it's the same strategy. And now we have 9 and 27. Well, 3 to the power of 2, or 3 squared, is 9, and 3 cubed is 27. So we're going to do change of base to both of them. So 3 squared, and we still have that x over 2. And here 3 cubed, and x minus 4. Now what's really nice here is these are inverse operations. So we're just left with x is equal to. Then we can go 3x minus 12. And I'll subtract 3x off of both sides and divide both sides by negative 2. So we get x is equal to 6.